A kite 100 feet above the ground moves horizontally at a speed of 9 feet per second. At what rate is the angle in radians between the string and the horizontal decreasing when 200 feet of string have been let out? So we want to make sure we can draw a picture first. So if it's moving horizontally at a speed of 9 feet per second, that means it's moving to the right. Okay, and we know that the height of the kite is 100 feet. So that means that the height of the kite here is going to be 100 feet. Okay, and so it's saying here that it's decreasing when 200 feet of the string have been let out. So that means that 200 feet of the string have been let out. So let's go ahead and then label our graph here. So we know that here is the kite. Okay, we know that it is 100 feet above the ground. We know that this represents X, and we know that there's a string here, and we'll call that Z, that has 200 feet of string. And so what does this angle theta represent? Okay, so we're given a few different pieces of information in this problem. Okay, first, in this problem, we know that it is moving at a rate of 9 feet per second. So that tells us that dx over dt is equal to 9 feet per second. So what we want to do is we want to find out the equation for theta. So recall here that this is going to represent the adjacent side. And this represents the opposite side. So for step 2, we know that the cotangent of theta is equal to the adjacent over the opposite side. So therefore we know that the cotangent of theta is going to equal X over 100. Okay, so let's solve for X. So if we solve for X, we're going to multiply both sides by 100. And if we multiply both sides 100, then X is going to equal 100 times the cotangent of theta. Okay, so now what we want to do in step number 3 is to then differentiate with respect to t. So we're going to differentiate this equation. X equals 100 times the cotangent of theta. So when we take the derivative of the left side, we get dx over dt. And then that's going to equal, well, the outside is 100 cotangent. And the derivative of 100 cotangent theta is going to equal negative 100 times the cosecant squared theta. And then, using a chain rule, we then take the derivative of theta with respect to t. So this is d theta over dt. So again, we're looking for at what rate is the angle in radians between the string and the horizontal decreasing. So we're looking for d theta over dt. Well, we know what dx over dt is. Okay, we already know that that represents the rate of dx over dt, which is 9. Okay, and so now we need to find out what is the cosecant of theta. Well, we know that the cosecant of theta is going to be the hypotenuse over the opposite. So that's the hypotenuse over the opposite. So we know the hypotenuse, which is the 200 feet of string. So that's 200 over the opposite, which is 100. So 200 divided by 100 is going to give us 2. Now we need to take cosecant and then square that value. So we're going to take 2 and then square that, which is going to give us 4. So now let's go ahead and then fill in our given information here. So we know that dx over dt is equal to 9, and that's going to equal negative 100 times 4 times d theta over dt. So we end up getting 9, which is equal to negative 400 times d theta over dt. Divide both sides by negative 400. So we get negative 9 over 400, and that's equal to d theta over dt. And so therefore, our answer would be the following. Negative 9 over 400, and that would be radians per second.